Hello friends, I welcome you in lecture number 4 on gamma distribution. In this lecture, we will discuss one more question which was asked in GTU Summer 2020 exam of gamma distribution. First, we understand what is this question. Suppose that the time it takes to get service in a restaurant follows a gamma distribution with mean 8 minutes and variance 32 minutes. Suppose you went to restaurant at 6:30 p.m. What is the probability that you will receive service before 6:36 p.m.? So here it is already given that this is the problem of gamma distribution and the random variable is the time it takes to get service in a restaurant. Our random variable under consideration is the time to get service in a restaurant. So it is given that the time to get service in a restaurant is a gamma random variable with mean mu equal to 8 minutes and variance sigma square equal to 32 minutes. Now it is given that suppose you went to restaurant at 6:30 p.m. Suppose some customer or you went to restaurant at 6:30 p.m. and it is asked that what is the probability that you will receive service before 6:36 p.m. So you can see you are asked to find the probability that you will receive service before 6:36 p.m. if you went to restaurant at 6:30 p.m. That means the time to get service is less than this time period. You will receive service before 6:36 p.m. if the time to get service is 6:36 minus 6:30, that is it is less than 6 minutes. If value of capital X, which is the time to get service, is less than 6 minutes, then you will receive service before 6:36 p.m. So the required probability is nothing but probability that this time to get service is less than 6 minutes. Because it is given that suppose you went to restaurant at 6:30 p.m. and you are asked to calculate the probability that you will receive service before 6:36 p.m. So this is the gap of 6 minutes between these two times, and service will be before 6:36 p.m. if this time to get service is less than 6. That means we are asked to calculate the probability that capital X is less than 6. Now we are given the mean and variance of this gamma random variable. It is given that capital X is a gamma random variable with mean mu equal to 8 and variance 32, and we have to calculate this probability. Now we are given this mean and variance of gamma distribution, and to find out this probability we will require the probability density function of gamma random variable. This probability will be equal to integral of PDF of gamma random variable with respect to x from 0 to 6. So first we have to decide what is the PDF of this random variable x, and to decide PDF we know that if we have gamma distribution, then we have either parameters lambda and alpha in the PDF, or we have alpha and beta parameter form of PDF. To write down the PDF of gamma distribution, we must have these two parameters alpha and beta, or lambda and alpha, where we know that lambda is 1 over beta. So first we have to decide what is the PDF of gamma distribution whose mean is 8 minutes and variance is 32, and once we decide these two parameters we can find out the PDF corresponding to this random variable x, and then we can calculate this required probability. So that I have done here. First I have written all these things, and then I obtain values of these parameters lambda and alpha using these two mean and variance. So we can write systematically in this way. Suppose capital X is the time to get service in a restaurant in minutes. Given that X is a gamma random variable with mean 8 minutes and variance 32 minutes. And it is given that X follows a gamma distribution. And we know that if X follows a gamma distribution with parameters alpha and beta, then mean, that is expected value of X, is alpha times beta, and variance of X is alpha times beta square. This is another notation. So it is given that mean is 8 minutes. So we put alpha into beta equal to 8. This is given expected value of X is 8, and we know that expected value of X is alpha into beta. That means we have alpha into beta equal to 8. Also it is given that variance of X is 32, and we know that variance of gamma random variable is alpha times beta square. So we replace this by alpha times beta square, that is given as 32, and this alpha times beta square I can rewrite as alpha times beta in the bracket into beta equal to 32, and this I can use here. I put alpha into beta equal to 8, and I will obtain 8 times beta equal to 32. That gives me beta equal to 4. And if we have beta value, we can find out alpha from this. So we are using alpha into beta equal to 8, and we put beta equal to 4 here, and we obtain 4 alpha equal to 8. That means alpha equal to 2. So we have obtained two parameters alpha and beta, which are required to write down the probability density function of gamma random variable. So now we can write down PDF of gamma random variable. We should remember this formula: fx equal to 1 over beta raised to alpha times gamma alpha x raised to alpha minus 1 e to the power minus x over beta if x is positive and 0 elsewhere. So here we put alpha equal to 2 and beta equal to 4. We substitute alpha equal to 2, beta equal to 4 in this PDF, and we obtain this 1 over beta, that is 4 raised to 2 into gamma 2 x raised to alpha is 2 minus 1 e raised to minus x by 4, and if we simplify this, gamma 2 is 1. We can use properties of gamma function. Gamma 2 can be written as gamma 1 plus 1, that is 1 factorial. We know that if n is integer, gamma n plus 1 is n factorial, and this is 16. Gamma 2 is 1. This is x raised to 2 minus 1, that is x, times e raised to minus x by 4. This is the PDF for given gamma random variable. Now we can find out that required probability. We are asked to find the probability that service will be received before 6:36 p.m. if we went to the restaurant at 6:30, and we are asked to calculate the probability that service will be received before 6:36 p.m. That means time to get service is less than 6 minutes. That is, capital X is less than 6, and that is equal to 0 to 6 fx dx, and value of fx for x positive is 1 by 16 x e raised to minus x by 4. So that we write here, and then we integrate this. Okay, first we put fx equal to this value. 1 by 16 is independent of x, constant can be taken outside integral, and then we integrate this with respect to x, and we consider u equal to x, v equal to e raised to minus x by 4, and we apply integration by parts, which is u as it is integral of v, that is denoted by v1, minus derivative of u, which is denoted by u dash, times integral of v1, that is v2. So in that way we can apply this integration by parts. So here first I keep x as it is. Integral of e raised to minus x by 4 is e raised to minus x by 4 divided by coefficient of x, which is minus 1 by 4, minus derivative of first bracket, which is 1, integral of this second bracket, that is e raised to minus x by 4 divided by minus 1 by 4 times minus 1 by 4, that is going to be 1 by 16. And first we rewrite all these things. We can take e raised to minus x by 4 common. This I can rewrite as minus 4x minus 16 and e raised to minus x by 4. We can also consider minus 4 common, and we have x plus 4 times e raised to minus x by 4. We can take minus 4 outside, it is independent of x. Then we put x equal to 6 as upper limit. Then we have 6 plus 4, that is 10 e raised to minus 6 by 4, minus for lower limit we have 0 plus 4, that is 4 into e raised to 0. E raised to 0 is 1. So contribution from x equal to 0 is 4 only. And then we can take 2 common again from these two terms, and we have 5. This 6 by 4 is 3 by 2 minus 2, and this 2 will get cancelled, and we have minus 1 by 2. 5 times e raised to minus 3 by 2 minus 2. And if we calculate this using scientific calculator, we will obtain minus 0.88435 up to 5 decimal places. This is also negative, 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 positive, and this is the required probability, 0.442175. So probability that you will receive service before 6:36 p.m. is 0.442175. So in this way we can calculate this type of probabilities for gamma distribution easily. Here I have used this parameter form, alpha beta parameter form, for gamma distribution. And if we wish, we can use lambda alpha parameter form also. If we consider beta equal to 1 over lambda here, we will get another PDF of gamma random variable. And if you use beta equal to 1 by lambda, you will have lambda alpha parameter form of gamma PDF. And if you are using that parameter form, then also you will get same PDF. And if we are using that lambda alpha parameter form, then for that parameter form, mean of gamma random variable is alpha over lambda and variance is alpha over lambda square, because we are using this relationship beta equal to 1 by lambda. If we are using alpha beta parameter form, which we just used, then expected value of x is alpha into beta and variance of x is alpha into beta square. So here we are simply replacing beta by 1 over lambda. So that is your choice, whether you want to use alpha beta parameter form or lambda alpha parameter form. So I have done this same question using this lambda alpha parameter form also, and I get the same PDF. Suppose I use these parameters lambda and alpha, then I will have expected value of x, that is mean, equal to alpha over lambda and variance is alpha over lambda square. Now it is given that mean is 8, therefore alpha over lambda is 8, and variance is also given as 32, therefore alpha over lambda square is 32. This I can rewrite as alpha over lambda equal to 32 times lambda. I consider 1 lambda on this side. Now alpha over lambda is 8, so that I substitute here on this side. Alpha over lambda is 8, and I obtain lambda equal to 1 by 4, and I can obtain alpha by taking lambda equal to 1 by 4 here. From this I can write alpha equal to 8 times lambda. Lambda is 1 by 4, 8 times 1 by 4, that is 2, and we find that alpha is 2 and lambda is 1 by 4. So if we use alpha and lambda, then we will write down this PDF, which is in the form of lambda and alpha, lambda raised to alpha over gamma lambda, gamma alpha, x raised to alpha minus 1, e raised to minus lambda x is positive, 0 otherwise. So here we put lambda equal to 1 by 4 and alpha equal to 2. Lambda is 1 by 4, alpha is 2, e raised to minus x by 4, and we can see this is going to be 1 by 16, gamma 2 is 1, this is x. So we obtain this same PDF which we obtain using alpha and beta parameter form. So that is your choice, either you want to use alpha beta parameter form for gamma distribution or lambda alpha parameter form for gamma distribution. This is using alpha beta parameter form, 1 by 16 x e raised to minus x by 4, and if I use lambda and alpha, I obtain the same PDF, 1 by 16 x e raised to minus x by 4, and our required probability is nothing but integral of this PDF, and we find that and we see that this PDF is same, either we use beta or lambda. So there is nothing special about that lambda alpha parameter form and alpha beta parameter form. You can write down both the forms from each other simply using this relationship, beta equal to 1 over lambda or lambda equal to 1 over beta. So this is very nice question and easy also. You are already given that given distribution is a gamma distribution, but you are not given the parameters of gamma distribution. Instead of that, you are given the mean and variance of gamma distribution. So you must be familiar with the formulas of mean and variance of gamma distribution. Using those two formulas, you will be able to decide the parameters of gamma distribution, and once you decide the parameters of gamma distribution, you can write down the corresponding PDF, and you will require PDF to obtain this probability. So this is all about this question, this session. I hope you like it. Thanks for watching.